So here we are now on page 2 of section 2.1, and we finished up page 1 with kind of the introduction to this page. So if you're just jumping into this page, you might want to back up just one video and watch the bottom of page 1 for 2.1. We use the book introduction of solving equations right at the bottom of that page, and that is to use the addition property. And what it's really telling us is the idea of we have to keep things equal, have to keep things in balance. So what I want to highlight before we jump into solving is the critical rule for solving equations, and that is that what you do to one side of the equal sign, you must do the same thing to the other side. So what you do to one side of the equal sign, you must do the same thing to the other side. Right? It's that whole having a brother or sister, and well, that's not fair. They got more ice cream than me. Yeah. Well, we keep it balanced. We keep everything the same. This is sibling heaven right here. Is everything is always the same. There's no preference. There's no favoritism. Everything's always totally equal. Not real accurate in real life. Life isn't always fair, but if you are needing some fairness in your life right now, go solve a couple equations. That'll balance everything out for you. So we're going to solve these two equations together. The first one will be y minus 5 equals negative 18. The next one will be z plus 13 equals negative 15. You've seen these before. If they seem familiar, they're at the top of page 1. Those were our original examples of what an equation would look like versus if you cover up the equals in the number. Now you're just looking at expressions. Okay, so expressions, equations. And again, I mentioned at the bottom of page 1, this book takes you through section by section and gradually adds more pieces to the equations, grows them. Pretty soon in 2.2 there's going to be something added to, multiplied by the variable, and then in 2.3 there's going to be parentheses and things that and like terms that you have to combine. So what we're going to do now is just I know what's coming, so I'm going to give you all the steps now. We can start practicing and rehearsing like a checklist, all the steps, so that you're ready for when these problems get more complicated, and they will. Okay, so but they will seem easy because you've been rehearsing it the whole time. Okay, you're just going to be ready for what's coming. So let's talk first about this set of steps that I'm describing. And for many of you, as your algebra past is starting to unrust and you're starting to remember some things, you could probably solve these in your head. You've probably done it already. So bear with me as I go through these steps, show all the details here. I know most of you are going to be able to solve these much easier than I'm showing on paper. But remember, our goal in mind is to be ready for, our plan here is to be ready for when these problems get harder as these sections of chapter 2 progress. Okay, so what is our goal? Always, when we're solving an equation, okay, when they ask us to solve an equation, our goal is to get x alone. Nothing happening to it, nothing multiplied, nothing being added or subtracted on one side of the equation. Okay. You may hear the phrase, isolate the variable. We tend to use isolate in a negative context in life. Isolation, it means being all alone, no one around you. The idea of a prison cell, isolation, or a timeout, it doesn't really have a positive connotation. But in this sense, it helps us solve things. And actually, that's really the intent of isolation in terms of when it's being used as a discipline. The intent is to get you by yourself, no distractions, to allow you to kind of think through what you did or what you said and kind of see see what would have been the solution to the problem, what you need to do now to solve the situation you've gotten yourself in, what you need to do to fix the damage that has been done. Not that there's damage in equations, but in the sense that we don't know what x is, and so it is solved. You're solving a mystery. You're solving an unknown here. So a couple different analogies there. The mystery is solved. So when you get that variable all by itself, you now know what the values is. Okay, so let's look at the steps. The first step is to simplify, and we've been talking about what simplify means. There's two parts to it. The first thing is to remove parentheses or any other kind of grouping symbol, and sometimes we have to distribute to do that. Sometimes parentheses just say, hey, look at me, I'm just holding a negative, or I'm holding a number so you notice it. Sometimes parentheses indicate multiplication, but sometimes the only way we can remove parentheses is to distribute. So that's if there's things being added together inside the parentheses, then we have to multiply, take that multiplication piece and go through those parentheses and distribute. The next thing we do to simplify is we combine like terms. So we've been practicing these simplifying steps so that we're ready for equations, okay? And we do this on both sides of the equal sign, this simplifying step. Now, again, I can't emphasize this enough. What we're going to see, especially in 2.1, is we'll just go, oh, doesn't need to be simplified, doesn't have parentheses, doesn't have like terms, okay? We're going to be able to check this step off. We're going to look for it, but then we're going to move right on because it won't be there for this first section. What we're doing is practicing for when it does show up, and it will in later sections, and we'll be ready. It won't feel like a brand new thing we have to deal with. Okay. So pick a side. What that means here is, you know, we're not picking teams or anything. We're not divvying up on the playground who's going to play what. You know, who's going to be on whose team for dodgeball. But we're deciding, and then we're going to move x to one side or the other of the equation, because sometimes x shows up in more than one place. So pick a side. So we're going to decide. You have the choice here. Okay. Some of you might have been trained it always goes to the left. Totally fine if that's your comfort zone, but you don't have to do it that way. It can land on the right. You have to decide what's going to work best for you, or maybe what's best in that situation for you, and then you're going to move x, and I'm going to put x in quotes here because it's whatever the variable is, to one side or the other of the equal sign. Okay, and the way we do that is we use opposite operations. And we'll look at what that means as we start to encounter that. But first we simplify, remove parentheses, combine like terms. Second, we decide which side we want x to be on. If there's more, this is if there's more than one x involved in the equation. Then we're going to ask ourselves, what's happening to x? Okay, and to answer that question, we're going to use our knowledge of order of operations. So we're looking at the variable and saying what are the numbers being done to it before we get to that equal side. And then we're going to undo what's happening to x. So we take that list of what we've said is happening to x, and we do two things to it. We reverse the order of that question, what's happening to x? Okay, so this question right here, we reverse the order of it, and we go, so it's like we go backwards through that list, and we use the opposite operation that we said was happening to x. So if 5 was being added to x, we're going to subtract 5 from both sides of the equation. Okay, use opposite operations. And again, we'll do this to both sides of the equal sign. That's the critical rule. Whatever you do to one side, you must do the same thing to the other. So this is especially important in the undo step. So this step right here, the undo, this is where you want to keep that balance. Whatever you're doing to one side, you do to the other. Okay? And finally, we want to get in a good habit of being confident enough in our mathematics that we also can know if we've made an error or not. And algebra is one of those beautiful things in life where we don't have to rely on other people to tell us if we're right or wrong. We can check our own answer. That's not a luxury in many classes. So this is really a cool thing here. So we want to check our answer. You can do this mentally or on paper. It's just a good habit to develop, okay? And what we do by checking is we're going to use our ability to substitute and evaluate. So we're going to plug into the original equation. This is critical, that it's the original. If you've done any of these previous steps where you simplified, picked a side, you had to move things around before you could start the solving process, okay? So these first two here are, this is the rearranging of the equation to get it to where it's in that ax plus b equals c form, okay? And then the 3 and the 4 is the actual solving of it, where you're isolating the variable. And then this final piece is the check, where you're finding if it's what you've done is correct or not. But you want to plug it back into the original equation, which would be all the way up here before you did any simplifying, okay? So before you did any simplifying. And I'm probably off the screen as I say that here. I'm realizing I'm way too far down. So the check happens before the equation, before you simplified. There. Sorry about that. Glad I caught it though before I just kept running off the page or off the screen. Alright, so we're keeping things balanced here. That's the critical rule, is to keep things balanced. That's going to be very, very important. Alright, so again, we're going to start with very basic equations. Many of you guys are going to be able to solve this without having to show as much work as I'm about to show. My point in what I'm trying to do is help train us for when the problems get harder. Okay, so let's look in here. I've got y minus 5 equals negative 18. Our goal, always keep your goal in mind. That's important with anything. In life, school, this class, this problem. We want to get y by itself. Okay. So we simplify. The very first thing we do is look, are there any parentheses in the way? Anything going on? And in this case, no. So we do a quick check for parentheses. Are there parentheses? Nope, checked for it. Are there any like terms on either side that we need to combine? So it's like you cover up one side of the equation and look at it. Nope, it's just plain old negative 18. Cover up the other side, look at it. Anything that you can combine, like terms? Nope. So we've checked for like terms. They're not there this time. Okay? Again, we're just training ourselves for when they get more difficult. Then we look to see is the variable, in this case y, is the variable on more than one side. Okay? Do we need to pick a side? Nope, y is just hanging over here on the left, so that's already done for us. Think of it as kind of pre-made meals. This is like the fast food, the drive-through of equations here. We don't have to boil the water and chop up the lettuce for the salad and brown the meat for the meat. I mean, we don't have to do all the prep work, okay? It's already kind of there, ready for us to dig in. So we are at the solving stage. So we need to ask ourselves, what's happening to x? And again, this is going to seem like overkill, but what's happening is that we're adding 5, or I'm sorry, we're subtracting 5 from both sides. So what's happening, so here's my little what's happening list. The first thing that happens to y, and in this case the only thing, is that 5 is being subtracted. Okay, so we would write subtract 5 here. Now another way you could think of that is you could think of it as you just write that y minus 5. Okay, so as you look at it in terms of order of operations here, we say you've got y and then we subtract 5 as we go across the page. Okay. Now our next step is to undo that. Okay, this is the most basic type of equation, but they will involve more steps as you move on. So let's look at undoing what's happening to x here. So go up the list. Now there's only one thing in the list, or in this case, if you were to write it in terms of just numbers and letters, you would go back from right to left on the list. In this case, we're going to go up the list on our verbal, or if you make a variable statement, just write it out, what's happening in numbers and letters, then we would go the opposite direction back through the list. But in this case, as we look at the green here, it says to subtract 5. Well, we're going to do the opposite of that in reverse order. Well, there's only one step. So if there was one step, in the beginning, there's only one step to add. So we do the reverse of that, or the opposite of that, and that is to add 5. Another way to think of it is if I were to go backwards here and undo everything that's happening to y, I'd come this direction, and the only thing that's happening is a 5, so I undo it by adding 5. And what you've created here is this little checklist for yourself of how to solve. So we're going to add 5 to both sides, or it tells us we're going to add 5 here. So we're going to do that. We're going to add 5 to both sides, following the critical rule. What we do to one side of the equation, we do to the other. Now, I draw this line underneath. This is pretty standard for a lot of mathematicians. There's nothing magic about the line, but it's just a way to kind of show that I'm going to now combine these two lines together. I'm going to bring them down here. So what happens is the negative 18 plus a positive 5, you're going to get a negative 13. If you're still struggling with positive and negative numbers, adding and subtracting, please get some extra help. Okay, we are in chapter 2 now. We're going to assume that you can handle this. The equal sign comes straight down. The minus 5, which is really plus a negative 5, and the positive 5 here, these added together give you 0. That's the whole point. Our point was to get y by itself, to undo what's happening to it. So that was the point. The y just comes straight down. So our answer here is y equals negative 13. I know you could have gotten that a long time ago without showing any work, but I'm just going to build the steps here so it starts to make more sense to you, so you're ready for it to make sense when the problems do get harder. But you can do a quick check here. So the check might look something like this. You go back to your original equation, y minus 5 equals negative 18, and we're just checking to see if negative 13 works in that. You can do this in your head or on paper, but negative 13 minus 5, negative 13 plus a negative 5 is another way to think of that. You do get a true statement, negative 18 is equal to negative 18, so we've checked it. We have solved our our equation. Now, I mentioned this both in class and in our last set of videos, but we're going to start training ourselves to use what's known as set notation. It's just to take our answers, set notation there, and put them inside a set, kind of give them a little framework, hold them aside. That's our answer. So our answer here is negative 13. When we have more than one, we'd put a comma there. And there's actually an even fancier, you thought this looked fancy, there's even a fancier way to do set notation, but this is plenty for right now. Okay, that's about 10 minutes, so I'm going to pause right here and go ahead and we'll do the second example in a fresh video. So I'll see you at the middle of the page in just a moment.